In this lecture, we are going to use the DS3231 real-time clock module that has battery, where when it is disconnected from power totally, it will keep the time running. We are going to explain the module, how to use it, and I'm going to show you simple code that we can read the time from this and display it on serial monitor. After that, I'm going to test the alarm and show you the built-in alarm of this, which are 3 alarms, and we will trigger a load or something so you know how to use it. Then we are going to build a clock using LCD screen so we can display the calendar, date, time, month, year, and the full time on the screen. And after that, I'm going to demonstrate and show you how to have unlimited alarm, because this has very limited alarm that you can set, but I'm going to show you how to have unlimited alarm when the code will be provided. This unlimited alarm also will have a switch where you can press it and will turn off the alarm when it is triggered. Then I'm going to use the HT16K33 4-digit 7-segment LED display so we can build a proper bright clock that you can view it from far distance. Let's get started with this. Hi, welcome to an Arduino step-by-step course by RoboJax. This is a module based on DS3231 from Maxim Integrated. It is a clock module. They call it real time because as soon as you power it up, the clock will start running. You can set the time, date, month, year, second, full calendar. And when the power is running, this runs. But when the power shuts off, if you have provided this battery, the battery is DS2032. It's a 3 volts. You can also put a rechargeable. This is a lithium battery. So this will keep the clock running even if you disconnect it from power. And this can be used in many applications. It works based on I2C communication. And here are a number of pins that we have. We have ground, VCC. Ground will be connected to ground. VCC, this needs 5 volts. SDA and SCL are the pins that are needed for I2C communication to set values or read the value from this chip. We have square wave output, SQW. Through the code, you can set this. The library that I've included has that option, so you can set the frequency and get the output. And this is a 32 kilohertz clock frequency that this chip is running. Also, you can get that as an output. Sometimes people need it for some reference or whatever application that you need. This comes with, on this side, it comes with 4 pins. Usually people will use these 4 pins only. So I'm going to use only these 4 pins. When the connector arrives, you can solder it in here if it is not soldered, or if you just want 4 pins, just solder 4 header pin on this side. This LED will turn on when external power is connected. Right now there is a battery, it's holding the time. If I disconnect it from power, you see that LED will turn off. It will not consume the power from the battery. As soon as you remove this, the time will be resetted, and you can set it from Arduino, which I'm going to show you next. The module without the header is 38.5 millimeter, 22.8 millimeter wide, and it has 12.4 millimeters depth. If you want to know the length of the pen headers, 44.6 millimeter is the length. If you're concerned with weight, including the battery, it weighs 8.7 grams. Here is the official Maxim Integrated web page, including the data sheet. There is the accuracy ±2 pulse per million at 0 degrees up to 40 degrees, and it has 2 time of day alarm. And here is the most important part. Many people will ask the active supply current. When you connect it to 5 volts or 5.5 volts, it's 300 microampere. Here is our square wave output frequency, and there are 2 register value that you set it, RS1 and RS2. Based on this value, either you can get 1 hertz, 1.024 kilohertz, and all these, and then when you set it at 1 you will get 8.192 kilohertz output. I'll provide you the link if in case you need further information. Let me explain now the wiring. This module we have used only 4 wires, VCC, ground, and then we have SDA and SCL. And SDA and SCL, SDA is A4, SCL is A5. Here, as you can see, here is SCL, the brown. From SCL is connected to the last one. SDA is connected using black wire to the A4. If you're using other devices, for example, UNO Ethernet, SDA is A4, A5 is SCL, Arduino Mega, 20 is SDA, and 21 is SCL, and the Northern Duo, they have been all mentioned. I will provide you the link for this as well. Ground is connected using ground wire to the ground here in Arduino, and VCC is connected using white wire to 5 volts. And if your Arduino has SDA and SCL at this point, you can connect it there. It will work. Wiring diagram for DS3231 module. We are using only 4 wires, 2 wires ground and VCC to power this app, and the SDA and SCL, this is the data and this is the clock, which is used by I2C communication. Ground is connected using gray wire to the ground. VCC is connected to 3.3 volts. SDA is connected to A4. SCL is connected to A5. Now let me explain the code. For the code, you have to first download the library. I will provide you the link as a zip file. I will give you the link. It will be from this website. You click on download, and here download the zip, or you can download it directly from robojax.com. Once you download it, and go click on sketch, include library, add .zip library. Once you click, wherever you have saved it, point it to that. Browse and find it. For example, this is one of the zip file. This is just an example. You will select the zip file that you have downloaded and click open. Once you click open, it's done. Close this Arduino IDE and reopen it. If you do not close it, you will not be able to see it in the list. Then after restarting, click on File, Examples, scroll down until you see Arduino DS3231 Master. I cannot explain everything, just click on Simple, and I will explain it to you. Wire.h, this line says that include this wire. That's for communication between Arduino and the device. So this is for the actual module. All the information, communication, all the protocols is written here. And from this class, we create an instance of it and we call it clock. From this class, also we create another object, we call it DT. This will be part of this library that you download. Inside the setup, we initialize a serial monitor with 9600 baud. Clock.begin initializes the clock, and here this line sets the time from your machine. Clock.setDateTime. This is taking the date, there is a comma, and then time. This is 2 underscore. If I highlight it, you will see 1, 2. Do not change it. But if you wish to set your own time, you can type manually and set it, for example, 1950, whatever you want. But this is taken from your computer. From my computer, if I change my date and time in my computer, then whatever I have, it will be set. Once you do it one time, because the module has a battery, then you don't need to run this every time. You can comment this out, so the old date and time will be set. Up to you. This code inside the loop will run continuously, so if clock.getTime and date will get time and date, and we store it in this DT, and this is printing raw data, and then from DT dot, these are the properties, dt.year will print the year, dt.month, and we print a dash here, dt.day, hour, minute. This will be 2019, this will be 6, the month, today's month, and then the day, hour, minute, and second. And then we wait for 1 second and we continuously print that. So you can play with this and you can print it any way you want. Explain the alarm, go to examples, master, and then click on alarm. Same thing, this is exactly the same, and here we set alarm. Here they disable first alarm, clock of alarm 1 false. So this is clearing previous alarm that is already set. So we say disable the alarm and then clear it. After this, we set the date and time. For this demonstration, we are setting 2014, for example, 4/25. This is the month and that's the day, and then hour, minute, and second. But like the previous example, you can leave this and actual date and time will be there. This example makes it easy for demonstration because that time is 00, and if I set it 20 seconds, it will be 20 seconds from this. Otherwise, the clock on your machine have to reach that time to trigger the alarm. And here are different examples. This is setting the alarm every second. This is for every minute. You can set it for every minute you want. Every 20 seconds in each minute. For example, here, this will go match second. This was saying every second. This is match second. And here this is match minute, every 1 minute. And these are examples that are already set, but it fits with every need that you have. For example, this will fit for every 1 hour, 1 minute and 20 seconds of each hour. So you see, match minute second. Set at each day at 1 hour, 10 minutes and 30 seconds. Hour, minute, second. And here this will be at 7 and 25th day. So this means when the day is 25, it goes to hour 7, minute, and second at 0. So a little fancier. This is for every Friday. So remember, Monday is 1, means the 5th day, 10 hour, 40 minutes and 30 seconds, trigger the alarm. And this is checking the alarm settings. And then when we say check alarm 1, this is a method that comes to this function, and what it does is it sets the alarm 1, and we call it an object called A1, and for alarm 2 we call it A2. And here it checks if clock is alarm 1 set. If this is true, then we get the alarm and store it in A1, and we print alarm is triggered. And then here we check clock get alarm type 1, and here is all those types that we set: minute, hour, second. This will print the text for us. And if clock alarm 2, same thing, all of this will run. And then we come to the loop. Here it gives a time and so stores it here like before I explained it. It prints the date and time continuously for us, and if the alarm 1, it checks it. If it is triggered, then it prints this text. If alarm 2 is triggered, it prints this text. In my course in Udemy, I will explain this fully and will not skip any line because this video will be very long. The link for my course for Udemy will be provided in the video below. And then we wait 1 second and the loop will continuously check the same thing. This code will print a simple date and time. Let me upload it. And here it prints the 2019. This is the month and that's the day, and then hour, minute, and second. Hour is 24-hour format. Now click on File, Example, go here, and then this time select Date Format. Serial Monitor, you can click on Tools, Serial Monitor, or you can press Ctrl+Shift+M, or you can click on this icon here. this is printing a long format, so let me pause it from here, from the lower corner. Auto scroll is disabled. Now this line prints the day, the month, year, and the date, time in 24-hour format, hour and minute and second. And this is for the long name. Here, instead of 6, it also prints the name in January, February, March, and the rest is the same. Here, this is 12-hour format, and then this is Polish, you can change it. Then June, and today is Tuesday, and it shows the day in a year, then 61st day of year. And then the actual month has 30 days, it will tell you that one. And this is the Unix time. This is the number of seconds that has passed since 1970. I will provide you the link if you want to know about it further. So this is a different way to display. And now let's open the example for alarm. Here, now this time select alarm. In this one, you can set the alarm as I mentioned, and it will display the alarm for you. Right now, the time have been set manually 2014. That's the day, that's the month, and day, hour, minute, and second. So from now on, this is the alarm. Here it prints and it says that alarm is in 20 seconds and in 1 minute. As you can see, this is 0, 1. And once you open the serial monitor, by the way, it resets it. You see, if I close this and open it again, it will run again. So be careful about this when you run serial monitor. Otherwise, if you do not run serial monitor, the alarm will perfectly run here, and you will see after 20, you will see that it will print alarm triggered. Alarm triggered because 20 seconds. And the next alarm is at 1 minute, so pay attention. When this reaches to 1 minute, alarm will be triggered. I will modify this code after the second alarm, so the buzzer can buzz, so this way you know better that alarm have been triggered. And in the same way, you can run it to turn on a light via relay, or a timer that opens the door or something, or locks the door based on some time. So this is now 52. As soon as this digit becomes 1, you will see the second alarm triggered. Now, based on the time and date that we set, you see second alarm triggered. Here is the wiring diagram for DS3231 real-time clock module with buzzer and LED. This portion is exactly the same, 2 wires for VCC and ground, and 2 wires for SDA and SCL, that's for I2C communication. On this side, we are using alarm 1, output is from pin 2, and alarm 2 is from pin 3, and this is the ground, which is common. On the breadboard, I've connected ground here to this portion, the side that has blue line, so all of this has ground. And pin 2, when it is on, the pin is connected here, it goes through this 5 volts buzzer. From this side, the pin is connected to the ground and it buzzes. At the same time, because this is 5 volts, I have connected the resistor here to this anode side of LED, and the cathode of LED is connected to the ground. When the buzzer buzzes, the LED also will turn on. This resistor, you can put any value between 330 ohm to 1000 ohm or 1 kilo ohm. It's fine. 330 will be the maximum brightness. Lower than that will damage the LED. But if you put anything 300, 400, 500 or higher, you just reduce the intensity of LED, but it will lit and you can see it. Pin 3 is for alarm 2. When this is high, the same way, just buzzer 2 or B2 will turn on, and from the other side it's connected to the ground, so it buzzes. And from the same pin, when it receives the signal for buzzer, we also connected a resistor to this LED, and the other side of LED, the cathode, is connected to the ground, so this will also turn on. As the buzzer buzzes, the LED will turn on as well. I'm going to demonstrate the alarm feature. When the alarm is triggered, actually the buzzer will buzz and also the LED will lit. This is for alarm 1. Alarm will run for a few seconds and will turn on, and then for alarm 2 there is a green LED, and this alarm will beep few times and will turn off. And here is the code with the alarm that I have changed it so you can control a buzzer. Everything is the same except these two lines. I've defined alarm 1 pin number 2, and for alarm 2 pin number 3 you can change it if you wish to use other pins, but now these two variables are available. And here, using pin mode, alarm pin 1 as an output, we are setting the pin. This is pin 2 and this is pin 3. We set them as an output, and this portion is done. The rest is the same when we are going inside the loop. Here, this is the loop. Inside the loop, alarm 1 triggered. Below this line, I've written digital write alarm 1 pin high. This means turn the pin 2 high, so the buzzer will turn on, and we wait for 3 seconds. It will buzz and then turn it off. This means the low mean turn it off. And that was for alarm 1. For alarm 2 here, after this line, I've added alarm pin 2 high 100 milliseconds and then turn it off using the low command. Wait for 300 milliseconds, turn it on, and then off, and then on. So this makes beep beep beep, and after that it exits. The last one is low, so the buzzer will turn off. This is the demonstration of this alarm. I'm turning it on and opening the serial monitor. So in 20 seconds, this is the buzzer 1, and the light will turn on, and it's for 3 seconds it will turn off. So pay attention to this number. And then this is the alarm 2. It will beep few times, and the light also will run now. So 3 seconds. That was turned off. Now, as soon as this turns 1, you will see the beep and the light, and that's it. So you can do whatever you want with the alarm. We're going to learn how to build an LCD clock using Arduino and DS3231 real-time clock module. And here is now the wiring for the LCD. I've connected ground to this ground of Arduino. VCC is connected to 5 volts, and this pin is SDA, second last pin of Arduino, and SCL to the last pin. The LCD is completed. See, clock module, you can connect either this side or this side, doesn't matter, but we are using only 4 pins. Ground is connected to ground, VCC is connected to 3.3 volts, and then SDA is connected to A4, SCL is connected to A5. And here, if you want to use a breadboard, then from A4 get a wire to this side, the red line. All of this will be now SDA, and A5 is connected to the second one. So this that's at the edge, this will be SCL. Now we can connect up to 128 I2C communication devices with SDA and SCL. And now here SCL is connected to this side, which is SCL, and I have connected another wire for SCL of LCD. And then SDA is connected to the red side, this red line. This is now SDA, and orange wire is also connected to SDA of LCD. For LCD, we have to install this library. I will provide you the zip file. Download it on your computer, save it, and then click on Sketch, Include Library, add .zip library, and then point it to where you have saved it. For example, if this was inside a download, go select it by clicking on it and then click Open. It will be installed. From this class, we create an object called LCD, and we pass the I2C or I2C address. 16 means 16 characters, and then this 2 means 2 lines. This 1, 2 lines. This, I know the address 0x3f, that's the address, but you need to get the address by using the I2C scanner So I give you this code, copy and paste it, and upload it to your Arduino. We don't worry how it works. After uploading, just open the serial monitor, and here it reads the address for you. We have defined here days of week in this area, so we have typed all these. You can change them as you wish, make them shorter, longer, or some other characters. But remember, the LCD does not support every language and every character, so you have to try and see which one works. And also the same way for the names. This 7 means we have 7 string name of the weeks, and then 12 is the length. So if you want to always make it shorter, you can do. Otherwise, if your word or text is longer, change this with the longest one. The same way this 12 is. For example, if you see September is the longest one, I just put 12. So if your word is the word that you're using is longer, change that. Otherwise, it will work fine. And the most important thing for you would be this one, to set the time. If you want to set manual time, uncomment this and then type here the actual time. This is the year, month, day, and that's the hour, clock, minute, and then second. If you want to set the time that I've set this here, date and time from machine, from your computer, run this. But you don't need to run it every time. You just need it to run it once if battery is connected. Upload the code, and after that comment this out, because you don't need to upload it every time. But it's up to you, you can leave it. And the format is very simple on the LCD. Here we print this line says, this line clears the screen. This is setting line 0, character 0, line 0. So this goes with the line 0, the first line. We print the day. This RoboJax is an object, so day, and then we have space, and then we say print month name, and then RoboJax.month -1, because the month goes from 1 to 12, so we have to subtract it because of our array at the top, and then space, and then year. So this prints day, month, and year, and that is this one, day, month, year. So this portion was responsible for that. And then we print this hour. We set the cursor character 0, line 1. Now we move to the next line and we print hour with this. After that we print colon. So hour, and then colon, and then minute, colon, second, and then one space, and then day of the week. So hour, colon, minute, colon, second, space, and then days of the week. And then this one is actually getting the number between 0 to 6. So we are getting up to 7, and this will pick up the text from the top of the code. So if you don't want it, just comment this out. If you want to not show the second, do the same thing. So it will just remove those elements that you don't want to see or you want to see on the screen. Now this is another code where we can set unlimited alarms. As much as you want, you can set them in the code, and when alarm runs, you can reset it. Now I have set the alarm, the buzzer is here, the time is running. I have set the alarm at 1941 or 7:41, and here it is now 1940. When it reaches 41, this buzzer will buzz. This is a 5 volts buzzer that I have set, and we can reset or stop the alarm using this push button. So it says the alarm title as well, so I can turn it off like that. This is a free software called Fritzing. You can get it from fritzing.org. If I click, this is the address. This is a free software. And here is the wiring diagram with alarm, push button, and a buzzer. You can connect a relay if you want. case I've used only for one of the pins, one buzzer. The buzzer is 5 volts connected directly to ground and pin 11 here. The positive is connected to pin 11. The push button, one wire is connected to pin 2. The other wire is connected to ground here. For the real-time clock, ground is connected to ground. VCC is connected to 3.3 volts. SDA is connected to analog 4. And SCL is connected to analog 5. And here, if you want to use a relay to control an AC bulb or something, then you can use this type of relay. Here, this is the relay that has 3 pins. I have separate videos showing how to control an AC bulb or DC load, whatever you want. This is just a switch that turns on and off. So these are the side that you will connect your bulb, one in here and one in here. This AC bulb, this is a plug that will be connected to wall outlet, and the light will be turned on. The middle, at this point, I have disconnected the wire, one of the wire, the live wire here, and I've twisted them and prepared them. These two will be connected to the relay. Job of relay is to turn it on by connecting these 2 wires, turning on the light, and disconnecting it, turning it off. So this can be a bulb or a fan or any other load, the same way the relay will connect it and disconnect it. You will connect it like this. The middle pin is 5 volts. You will connect it to 5 volts. The last pin is ground. Ground is connected to this point. And this pin is labeled as S, like signal, and it is connected to pin 11. This is for the first one. For each, you will have separate relay if you want to control them, connect them. Connect the signal pin to the appropriate pin that you defined in the code. Let me explain the code for the unlimited alarm. Everything is the same up to here. After this, here we define alarms. This is an integer array with maximum elements of 6 each. So we can just put year, month, day, I've mentioned them here, hour, minute, and second, each separated with comma. So this is one alarm with opening curly parenthesis and closing. That's the main array. And this is one alarm, that's a closing. After that, we put a comma, that's the second alarm. This is a third alarm, and you can put more if you want. Just define them here. Whenever you want the alarm to be triggered, just put the date and time, and it will work. This is for the code, calculating the length of this array. I want you to be free, so whatever you want, it should work. And here, alarm name. For each alarm, you can have a name. For example, the first one is work, the second one is pet food, third one is sleep, whatever. So this is just a name. But the length of this text, I set it to 10. If you want to put longer text, count them 1, 2, 3, 4, 5, and whatever it is, put here. So this is displayed on the serial monitor. Then these are the pins that alarm pin will be connected. For example, if you want to trigger a relay or buzzer or light or whatever, these are the pins. I have defined here 3 alarms, and I have defined 3 pins. And this is the reset pin, where we press a push button, this push button, to turn it off. One reset is enough for all, because it would have been very cluttered with wires to have reset for each. So when the alarm runs, you just turn it off, that alarm that is bothering you, and then the alarm will continue working when the time comes. These are the days of the week, the same as previous code that I mentioned. The length of the text is just 12. So if you type something longer than 12, it will be cut. And these are the month name. You can change them if you want. Below this, you do not change. And this for loop will print all alarms for us. Let me open it. Oh, not connected. Let me connect Arduino. So this is the first alarm, second alarm, and then third alarm, and then continuously it prints the date. And here, this is the most important one. If you want to set the time from your machine, just use this. This is needed only once. This is needed only once, so the time and date is set. Because alarm real-time clock has battery, it will remember it. So comment this if you're working continuously. Later on, you don't need to set it. And that's it. So we don't have to spend time on explaining them. These are the most important part that you can use, and it will work. In this video, we are going to learn how to use this DS3231 real-time clock and build a clock with this 7-segment display based on HT16K33, where we can display time or display second as well on the screen. I have separate video explained this HT16K33 7-segment display with Arduino. In this video, I'm combining these two together to make a clock. So we can set the clock to show 24 hours or 12 hours, and also it can show seconds after certain time. So you can set amount of time that only seconds will be displayed in here, and for how long. So we can set that in the code, and I hope this is the best and the most easy solution to have a very precise clock. Some people also ask that, is this always connected to a computer? No, you can connect a power adapter and keep this on. You don't need a computer once you program it. And if you want to set the time or change it, then because we have no buttons or switch or anything, you have to connect it back to computer and program it via Arduino IDE. Now let me show you the wiring. I have connected here 4 wires in order: 5 volts ground, this gray is ground, and then white SDA and SCL. This A4 and A5 are SDA and SCL, and here also we have SDA and SCL, but I connected it here because this clock module and then display, both of these work with I2C, so we need 5 volts for this, 5 volts for this, SDA and SCL for this, SDA and SCL for this. So for that, I've connected it to this point, and then I'm connecting the same color wires so we do not make mistake. You see, I've connected it. Now this for the clock module. For the clock module, this purple is connected to VCC. The gray is connected here to ground, and white is SDA to this SDA pin, and the last pin is black. Black is connected to SCL. If you're using other devices, for example UNO Ethernet, SDA is A4, A5 is SCL, Arduino Mega 20 is SDA, and 21 is SCL, and the Northern Duo, they have been all mentioned. I will provide you the link for this as well. So this is connected for the clock. For the display module, it has been connected exactly the same way: purple, gray, white, and black. So this is 5 volts, ground, SDA, and SCL. Now let me explain the code. I've used this DS3231 real-time clock library. This is the address from GitHub. You can get it. And also I've used this HT16K33 library from this address from GitHub. You can get them directly, but I will also provide you a zip file in case they change it and it doesn't work with this code. You will download this and save it as a zip file. Then go to Sketch, include library, add .zip library, and then point it to where you saved it. For example, if this was inside download and temporary, and if this was a file, just select the zip and click open. It will be installed. You can do the same thing for this. You can download it from GitHub as zip file, or you can also do it by clicking Sketch, include library, manage libraries. Wait for this to complete, and then type this HTK, then here type this HT16K33. Wait for it, and you'll see a lot of options, but this one by Rob Tellart, you see this name, so it is installed. In my case, in your case, you will see install button here like this. Just click and install it. This line wire.h is for I2T communication. Both modules are using that. This is the DS3231 clock class, which we included from library, and in here we create object of this class, and then also we create another object called time or DT from this class, which is included with this library. So once you download that, you will see it, otherwise you will get error. Then this is a class for the display, and we create an instance of the class here. We call it segment. This is an object with 0x70. This is the I2C address for this, and we watch the introduction for this because it will answer a lot of your question. Also watch the introduction for this, so you will not have any question left. And these are the most important part of the setting for this clock. For example, if you want to display the seconds, from time to time it goes and displays the second and comes back, set this to true. I'm going to demonstrate it. Otherwise, set this to false, this lowercase false. And then if you want to display every 5 seconds, every 10 seconds, put here millisecond. 10,000 means after 10 seconds, and now it's 5 seconds, 5,000. So every 5 seconds, it switches from clock to displaying the second. And then once you display it, it can be either blank, 3 blank or 4 blank, how many blank you will have, or you display it just based on time, which is, for example, for 5 seconds, how long you want to display the second. And here show leading 0 if you want to display 0 before the 8 o'clock, 5 o'clock, before 10, it will be 1 digit. So you can set this to true or set it to false. And then show second no blank. If you don't want this blank to happen, just say true. It will not blank, it will just count 1, 2, 3 up to 60. And this is part of the code, do not change it. These are called prototype for these two functions, do not change it. Inside the setup, we initialize the serial monitor with 9600 baud. If you click on tools, serial monitor, or press Ctrl Shift M, or if you click in here, you will see the serial monitor, and that is the text that is initialized by this. If this number in here on the right side on the lower corner is not 9600, you will not be able to see the text. Make sure to set it to 9600 so you will be able to read the text because this number matches that. Then this is just printing the text that you just saw. This line clock.begin initializes a clock, segment.begin initializes the 7-segment display. This is setting the clock speed for the 7-segment display. This line segment.display on, it turns the display on. This segment set digits, sets it to 4 digits. And here test, this is turning on all the elements quickly, showing you that the display is working and wired properly, and display off. Then we turn it off because some of the segments which were on, we must turn off everything and then give it 50 milliseconds, then turn it on. Display on, we'll turn it on back. And in this line, seg.brightness, we can set the brightness between 0 to 15. 0 means off, and then 1 to 15. So I set it to 10 at the moment. This is the most important line here. If you want to set the time from your computer time, just uncomment this and it will set the time, whatever is on your computer, this time here. So this will be set, date and time will be set. Sometimes you don't want that and you want to set your own time based on this format: year, month, day, hour, second, hour, minute and second. So these are in this order. You can set whatever time you want. And then inside the loop, which will run continuously, if we have set leading 0, then we set it to 4-digit. If it is not set to true, then it will go 3-digit and the 0 will disappear. And here, the time here, and this object, we say clock, get date and time. Now DT will hold the time. And segment display time, we pass hour, and then so dt.hour is getting the hour, and then comma, dt minute will get the minute. Here we can set the date and time format in terms of 24 hours. If you want 12 hours, just type small g. If you want the time to go with 24 hours, set capital G. Do not worry about reading 0 for the minute. It is automatic. It will not be customizable. So just remember capital G and small g. And if you want to print the time in serial monitor, you will just uncomment this and the time will be printed on the serial monitor. And this line says segment display time, and we send dt from that object. dt.hour, we get the hour, and dt.minute will get the minute. And then segment display colon 1 mean turn it on. This will turn on the colon between hour and minute and keeps it on for 500 milliseconds, half a second. And then we turn it off by setting this to 0 and keep it off. So half a second on, half a second off. And this line shows second no blink. If you set not to blink when you display the time, the second, then it goes to this function, which is show second 2. Otherwise, this means otherwise, go to show second 1, which I'm going to explain both of these. So show second 1, when it gets the blink count, let's say you set it to 3 times or 4 blinks, it will be stored in the count. And here, if the show second is true, if this is true, then we get the current time subtracted from the remember time from the top of the code. And if it is greater than the amount of time that you said every 5 seconds or something to run the code to show the display, then this counter will kick in. If the count is greater than 0, which is true initially, then we display get date and time here, and then set the digit to 2, so the other digit will turn on, so you can see only the second. And in this line we are subtracting that count because we are displaying that time once, and it means get the count, subtract 1 from it. So after setting the digits, we display the time by passing to this function segment display integer. I've explained this fully. Watch that video, please. Display dt.second. So this will display the second as integer and keeps it for 500 milliseconds and turns the display off, and then 500 milliseconds and turns it on, and then we just remember the time. And it goes and comes back, and this time it makes it subtract 1 more. It will become 2, and it comes back and makes it 1. As long as it is above 0, so that many times it will just blink. And if you do not select the blinking and you just want counter, then we remember the duration time that you select, how long it should display the second, and we store it in the count. And we do the same thing if display second is selected to be displayed, then we subtract the remember time and make sure to see if the time has passed for that amount of time. And this time again we do the count. This time every 50 milliseconds we subtract from the time, because the duration that you set is 5 seconds, 4 seconds, or something very long. So we just check that time, do exactly the same thing, and this time there is no blink, like, and here you see turn on, turn off. We do not have it. We just waste 50 millisecond time here, so the counter will update. When the second changes, you will see another number until the time passes and it is greater than this, and it will exit. And here, print time, this has been explained fully inside the DS3231 .air. It gets the year, dt.man gets the month, day, hour, minute, and second, and it will print it. And at the end, we just put a dash between them, between the hour and minute, we put colon. So we can turn it on and off from here, and that was the full explanation of the code. Now let me demonstrate it. When you set this to show second true, this is how it shows. It goes after a few seconds, comes back here after this 5 seconds, and it shows about 5 seconds here, and it comes back. So this is true. If we set this to false like that, let me upload it so you can see it. So now it will never go. And then here we have set no leading 0, and no leading 0 is here. If you set this to true, then the leading 0 will be displayed here. So, and display every 5 seconds. So let's set this to true. And now every 5 seconds, show second no blink, and this is no blink. Let's set it to false, which means blink. Now, when the code is uploaded, after 5 seconds, it goes there, and here it blinks. And this blink is determined by here how many blinks it makes. 3. If you set it to 5 or 4 or whatever, it will increase or decrease the blink. Let's say 6. So after 5 seconds, it goes there, and you have 1, 2, 3, 4, 5, and 6. And after that it comes back. And here, this is the display duration. So this display duration works only when you set it to no blink, because either we count or we wait this much time. So keep that in mind, that at any time either this works or this, based on whatever you set here. If you set it to true, blink, if you say no blink, then this has no meaning. It will go based on time. For example, let's set this to 10 seconds. Let's set it to 20 seconds and set this to true, no blink. And now pay attention. After 5 seconds, it will go there, and it will wait for 2 seconds, 20 seconds. So it was 6 plus 20, 25 or 26. It should just exit. This is the actual seconds coming from the clock module. So it's fully customizable with all the features that I've shown here. And here, this test, if you set this to 3, then when you upload the code at the beginning, it does 3 tests. Pay attention here, it will be very quick. Once, twice, and 3 times. We couldn't even see it, but let's put it back to 1. And let me show you this one. When you set this to print time, let's upload the code and then open the serial monitor here. Here it will display time continuously, time and date. You see, I set it to 2014. And here, let's see if it accepts 1868. In terms of date. And as you can see, it does not accept. Let's set it to 2021. And if you want to set the time for the for your clock, just, you see here, this time is around 8:54, 45. Until I upload it, the time will change, but still, let's see it. So now it's 8:45, and this time is now displayed here, and that's a second. You see, few seconds, this is behind, because when the code uploads, there is a delay that we miss until the code is uploaded. This is now the brightness with 10. If I set it to 2, it will be very dim, and you can see this is very dim, and I can set it to 15, which will be very bright. Now this is the maximum, so 10 would be suitable for my application. Please make sure to subscribe by clicking at the subscribe button in here. Thank you. Thank you for watching the tutorial from RoboJax. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos.